So confidentiality is, as I mentioned, what you probably think of with security, and that's where you have encrypted a message such that someone can't easily read it. So we've covered some basic ciphers, right? So I'm not going to go over what all of this means, but what I am going to point out is why is confidentiality alone not enough, right? So you might think, well, if we encrypt a message, that should be really good. Let's take the classic. So like 90% of security examples you look at seem to use some artificial military examples. So I'm going to keep that trend going. If you took the message attack the fort at dawn and we encrypted it with that Caesar shift that we learned previously, we'd have a message like this. And so let's not even worry too much about the fact that we could decrypt it. Let's just accept we have some encrypted message. And an attacker could see that message and not understand it, but they could see the results of it. So they could see this message happens, and then an attack happens on a fort. And later, there's some other message that's sent, right? And again, we can encrypt it with a Caesar shift cipher, and not necessarily need to know. So in this case, one of the artifacts of the encryption is that there's still some structure in the message. So even in the ciphertext, if all we have is the ciphertext, we see some structure in the lengths of it. And often what does happen is that it might not be so obvious, but there is some structure in the ciphertext potentially on less complicated encryption methods, or even the way the encryption is used might force some structure on it. So if we have, as an attacker, just took those two messages, right, and we just kind of jammed them together. So if I take this part of this message and put it here, and take this part of this other message and put it here, right, this message will then decrypt to a new valid message. So if I use that Caesar shift, it's going to say attack the fort at nightfall by the tower, right? And I, as the attacker, never actually needed to decrypt anything to do that. So one of the problems with purely encryption is that it does not stop someone from actually modifying the ciphertext, right? That might be a lot easier or more possible than you think. As a real example of this, and we haven't talked about the underlying cipher yet, so I'm jumping ahead a bit, but there's this cipher. All you really need to know is there's a cipher, AES, that's used in a mode, CBC mode. So we have this cipher algorithm, and basically you have this attacker with access to the ciphertext, this encrypted data, right? So this is normally the encrypted data that the attacker knows nothing about. In this case, it's a very good encryption, so there's no real details that they could easily discern from it. But you'll notice that the way the cipher is used, part of that ciphertext is directly XORed with something. So this means if you flip a bit in the input in the ciphertext, it's going to flip a bit in the plain text output here. So the attack is exactly that. It lets people flip single bits in the output plaintext, and it sort of garbles some of the data as well. Every other block it's going to make garbage. But this is a lot more powerful than you might think because, right, if you have stuff like security flags that are getting decrypted that says, if the system should go into debug mode or something like that, an attacker can actually directly access that. And if it's a very simple, or a simple enough system, that might have a known structure that they can figure that out. So this is a really real example. I know I gave sort of a hokey one here, but the basic idea applies really heavily. Another problem with this is like replay attacks, right? So if we have encrypt only, this will be a really common problem. You have a secure system using AES, something, but you can replay a message. So imagine you have some lock, right? And you have an unlock message. Well, if you just resend that unlock message, will the system unlock? It shouldn't if it's done correctly, but some poor systems will, right? So basically, it only tries to apply confidentiality. It does not try to apply any of the other requirements for a good security. So here's an example I like, again, to point out some hardware ones. This is looking at some wireless devices and some simple wireless devices. And it's actually doing it with some really cheap hardware to replay some of these various, unlock or on-off commands or stuff like that. A somewhat related attack. So this is actually a little further out from just pure crypto, but time of check, time of use. So this is a common class of attacks where basically a file or device or something like that is going to check at a certain point in time, and then at a later point in time, it's actually going to use that file. So basically, you have a point here where the identity or whatever it is verified, and a later point in time, the file is used without being re-verified, right? So this is why I like to tie it into that issue of just using encryption, right? It's not exactly that, but it's where there's no good validation done on the entire file at the correct times. Yeah, so here's an example. So I pulled this nice example from this USB attack that I linked below. And basically what you have is you have a device that you plug a USB key in. So this was shown on some smart TVs, I think. And you plug the USB key in, the smart TV checks the signature, right? So it's checking some stuff, passes validation, and later on, if it's valid, it reads the file in and then does stuff with it, right? So the attack is that you can present a valid file to the device, right? By valid, I mean like a file from the manufacturer, and later you can switch it. So if you then switch the file when it goes to use it, all of a sudden it's reading an invalid file, right? So there's a lot of similar issues that come up that come down to the fact that, in this case, it's actually kind of a logic error because they have tried to do the hashing and signing and stuff, but they've used it incorrectly. But there's going to be a bunch of issues that come up all related to sort of failure to correctly either do this at all or correctly do the next stuff we'll talk about. So the next stuff is going to get around the fact that confidentiality is almost always insufficient for a secure system. So it's a very important part of security because you often want to hide your data from someone, but it's rarely going to be sufficient for what we would consider a secure system. So let's go ahead and look at the other two areas we need to build into our system to make it secure.